Howdy everybody, and welcome back to our Legacy as Wizard aRPG tutorial. So today we are going to be talking about the ladder state. So let's get cracking. Just first on the list, you'll note this little line here. If you have that in your setup, just delete it because it no longer applies. Since there is actually subpixel movement, it's just X and Y fractioned out. So let's get over to our player object here, and we are going to add a new event. Other user event number 2. This will be our ladder state. And once again, copy and paste everything from our movement. Well, it's not going to be all copy and paste, but a lot of this will be copy paste. As far as it goes, figuring out how the ladder state would work was probably the hardest part of everything else in setting up this character. Just trying to figure out how to get the ladder to move, just was really hard on my end. Anyways, let's do some editing to this. We are going to eliminate some of this stuff because we don't need all of it, such as that. We have the image speed equals animation speed. If X underscore input, but we are not going to be moving in the X direction when we're on the ladder. We're going to be moving in the Y direction. So if Y input is equal to 0, then image speed equals 0. So I think that's everything for animations. So let's get on to the states. So states start off with our jump state. If we press the jump input, and now as far as it goes on the ladder, we are not going to be on the ground, so we want to be able to jump at pretty much any time. So Y underscore speed underscore it's greater than or equal to -2. So anytime our Y speed is normal, then allow us to jump again, because when we're on the ladder, we can jump as much as we want as soon as we get back to normal speed. Now, this should probably be max underscore speed. So that would make it better if you add in different objects that the character can move faster or whatnot. Then next, we have Y speed is equal to jump underscore speed, not plus equals. In this case, I just set it to equal to because I have no reason why. I think you could probably do plus equal to, but anyways, and we'll want to play the jump sound as well. However, we do not need to bother with changing the state or exiting, because we are not going to be changing the player's animation in any way. We're just going to be adding extra speed to their upwards movement. So next, we want to be able to return. We also don't need the ledge stuff either, so we can get rid of that. Next, we want to be able to return to the move state. So pound region move state. Don't need that for these regions. In region. So return to the move state if X underscore speed underscore does not equal 0. So basically, if the player types left or right in any fashion, they'll leave the ladder state and go back into a regular move state. Player underscore state stop move event underscore user state underscore and exit. So let's get rid of that. Oh, wait, got you inside of the jump state region. Get rid of that. Jump. Oh wait, there it is. Alright, so jump and move. Oh wait, actually, there is more to the move state as well. I didn't see it until I started closing off these things. See, that's why all this region and organization is good, because it makes it easier to see what you're missing. So We also need to make sure we're still on the ladder, so we don't climb into thin air like a mime, as my notes say. Because when we reach the top of a ladder, if we have reached the top of the ladder, we need to be able to detect that we're at the top of the ladder and stop trying to move up. So var underscore p1 is equal to tile map underscore get underscore at underscore pixel tile map underscore bbox underscore left bbox underscore bottom. So I found when I was studying the game that the player seems, and of course this is all my supposition, the player seems to rely on his left hitbox for detecting whether or not he is actually on a ladder. And when he detects whether he's on a ladder, then he goes into the ladder state and whatnot. So if underscore p1 does not equal 2 over here in our collision sprites tile sheets, 2 is this one here, which is just a flat bar that I use. Normally I use these ones for things like platforms, but in this game there are no platforms. You either have the ladder or solids. So if it is not equal to 2, so if on our bounding box left and at our bounding box bottom we are not at a 2, if we are not on a ladder tile anymore, then swap over to the move state. Let me just copy and paste the code in. There we go. State equals player states.move. If y speed underscore is equal to negative max speed, so or else we'll end up moving 1 pixel above the ladder and enter the jump state briefly. So we're basically saying here, if we've gotten to the top of the ladder but our move speed is still at -1, then set us back to 0 so that we don't continue to move up an extra spot. Then set our image index back to 0 and return it to the move state. Now for the, I think that's everything for the move state now. So next up, shoot state. So we can change a few of these conditions in the shoot state, I think, maybe. Let's see, shoot underscore input, object stats.magic greater than 0. Actually, no. Everything should be exactly the same right there. Let's see, shot, instance create, speed, max speed, direction facing, cast magic sound. Okay, yeah, we don't need to change our state though, because we are not going to be changing the animation when you're on the ladder. So just leave object stats.magic minus. And that should be everything for the shoot state. Next up, calculating our movement. So if x input is does not equal 0, then approach, etc. This should be as normal. This should be as normal. However, we are going to use a completely different system for our y speed because we are going to be moving up and down. This needs to remain the same as normal so that we can exit the ladder state. And of course, we are not going to be applying gravity while we're on the ladder. If y underscore input underscore does not equal 0, then do all this stuff here. If y underscore speed is less than max speed, then approach our max speed. Otherwise, approach our max speed by gravity. Otherwise, approach our max speed by acceleration. So we are applying gravity there. Just I probably don't even really need that there. You probably just use acceleration or something else, but that's the way I coded it, and it works, so I'm leaving it in there. Else, if our Y input is equal to 0, then again, approach 0 by gravity. And that should probably be by friction, but again, I don't really have any friction for the air in this game, so just by gravity as far as it goes. We're heading towards 0. And here's another really important thing with movement that should be known about. So in this game, when you move, you do tile alignment. So if you're close to the edge of a tile, rather than being stopped on the edge, you'll slide around the edge of the tile so that movement is fluid. So we're going to need to do a tile line here. Align Y. And back to when I messed up the grid. Again, this is kind of messed up in the same way because I messed up the grid in the project. And future projects will not have this problem. So if x underscore input does not equal 0 and y underscore input is equal to 0, so if I'm standing still and I'm just like really close to a ledge, then if y mod 16 is less than 2, or y mod 16 is greater than 12, which should give me within 4 pixels of an edge, or within 2 pixels on this side, I guess, then y minus minus. So I'm basically saying move me down very slightly if I'm within a couple pixels of an edge. And this comes into play when do I use this on this one? X input does not equal 0. Oh yeah. So if I'm at the top, near the top of a ladder, so let's actually show you it, and well, it won't work because I haven't actually put everything in here yet. Let me compile from my other project. Here we go. So here's the demo. If we come along and ignore the slow speed because OBS causes everything to slow down when I'm recording. So if we're up near the edge, see, I'm not quite over the edge there, but if I press left, my character moves up and to the left, which causes my movement to seem very fluid. And you don't really get caught and hung up on those ledges because of that. So that's a very nice feature. And this is just a bunch of math, figuring out how far you want to be from the edge. So if x underscore input does not equal 0. The main problem is just figuring out the logic and the math for how to get these things to work. Alright, so once we do that, we just move with collisions, make sure that we stay locked to the room, though we shouldn't really need this here when we're in the ladder state because we're never really going to be going anywhere that we get as close to the side of the room when we're in the ladder state. But, well, it's there, so we'll just leave it alone. That should be everything for the collisions and movement. What we need to do now is go back to our other states. Because remember, now that we have the ladder state in, we need to be able to get into the ladder state from the other from our other different states. So let's go back to the move state, and we are going to pop in this huge amount region of code here. So ladders are tough. I spent the most time agonizing over how I was going to get this to work. Yep, as I said. So if x underscore speed is equal to 0, because you can't go it, so you don't go into the ladder state unless your x speed is equal to 0, or the y input does not equal 0 and x underscore speed is equal to 0. So excludes the case where if you're moving while facing up, right, or left. So if you're shooting in the right or the left direction, because we don't want to be going onto the ladder while we're trying to shoot or something. So, or just going onto it on accident. So we have a bunch of tile map collision checks. So B box left, bottom, B box left, bottom 1, B box left -1, B box bottom. See, checking at the base, but doesn't really matter unless you have a ladder at non-16 pixel intervals. So if you have a tile that's off the grid. Also check one tile underneath us in case there's a ladder just underneath us. In the case where you're at the top of a ladder and you're walking along and you need to go into the ladders. Not only must we find a ladder, but it must be on the left edge of the ladder because we don't want to be grabbing other locations. Come back to the ladder state here. Oops. We need to make sure we're still on the ladder. Okay, well, shouldn't need to check to the left there that time. And last but not least, if we are going down, so B box bottom +1. So if underscore P1 is equal to 2 and underscore P2 does not equal 2 and Y input is less than 0, if we find a ladder and going up, then enter ladder state in X0 and execute the ladder state. If we are going down, if underscore P3 and underscore P4 and Y underscore input is greater than 0, going down, again same stuff, but we are moved 1 pixel down, so we are in the ladder block. That way we don't end up trying to immediately go back into the move state because it says, oh, well, we're in the move state. And because we'd go into the ladder state, and if we didn't have the Y++, we'd get into the ladder state, and then it would check to see if I should move back to the move state, and it would say, oh, I'm not on a ladder yet, even though I'm on top of one. So then it would move me back into the move state, and that would cause an infinite loop. So I added a Y++ there to prevent that. Image underscore index equals 0 and state user exit, so on and so forth. And that should get us into the ladder state properly whenever we are looking to do so. Alright, so next up, shoot state. I think that should be pretty much exactly the same code again. Yeah, it's all the same code here. So just copy and pasta. There we go. Again, actually, just as a reminder, the order these things are in does matter because it will check to see if we should go to the move state first. Then it will check to see if we should go to the jump state first next. And then it checks if we should go to the ladder state next. If you were to say put the jump state first, then it would check to see if we should go into the jump state first. And again, ladder, you check to see if we should go into the ladder state first. And as far as it goes, I think I have things set up well enough so that it shouldn't matter too much in this project, because if you go into the move state, then it will check and see if you're trying to jump, and it should move you into the jump state properly. But if you didn't have things set up the same way as me, then you might go into the move state, and then you'd end up with an extra frame in the move state that you don't want to be in the move state when you actually wanted to be jumping or something like that. So keep in mind the organization of these things. Alright, and last but not least, our jump state. The code should actually be slightly different here because we are going to be moving slightly differently while we are jumping than when we are just walking along. So let's take a look at that. Get rid of that, get rid of that, and there we go. So exclusive case should be the same, except we aren't doing as many tile checks because we don't have to check if a ladder is directly underneath us while we're jumping. so we can actually skip that a little bit. So that's pretty much the only difference. No need to check for going down here, as typically players will be pressing up while jumping. And I don't know of very many cases where you jump and then you try to go down on the ladder. But I mean, the instance could exist where you do that, but it's kind of a hard thing to do, so I didn't really check on it to see whether it actually would happen in the game. Anyways, I think that's everything for the ladder state. Actually, if we go over to the move with collisions, I think there's some ladder stuff in here I probably want to talk about. No, not directly. Well, getting back to where I was talking about if we're on the corner of a tile, then you want to slide past it. We have right here another two of these things here, which allows us to move to the left or the right, to the right or the left, if we are underneath something when we are jumping. Let's check it out. It should work, since that's all the code now. So yeah, we can jump. And now, you can't see, but I'm kind of pointing at this thing with my finger. You'll note that the ladder here, I've tiled all the way across with ladders, but you can actually get by with just tiling the very left corner of this. If you tile all the way across, well, of course I didn't put in the sprites. Of course, I always forget these. We got to add our sprites into the sprite table. So let's grab the code for that real quick. Ladder. There we go. So it should just be walk up for pretty much everything, because we are going to be walking up. I could also use the sprite walking down, but I don't like it for this. When you're going down the ladder. But it kind of really depends on your taste in that case. So let's try this again, and hopefully we don't crash this time. Jump along. There we go. Now we can actually climb up and down the ladder. As you can see, if we aren't moving in the left or right direction, it automatically jumps into the ladder state if we are on the ladder. And as you can see, because I tiled ladders all the way across, ladders actually work as a kind of platform. And I'm not able to go into the ladder state unless I am exactly on the ladder. See, like so. Because that's part of the exclusion principle for the ladder state when we're in the move state over here. If we find that there is a ladder to the left of us, if we find there's ladder to the left of us, then we can't go into the ladder state, because we don't want to be able to go into the ladder state if there's more ladder to the left of us. Anyways, so yeah, it's kind of a bit of a preference there on how you do the ladder, if you wanted to be a full platform kind of, or if you wanted to just be able to only when you're walking along the left or right, the left side. Yeah, the other thing I was talking about was, as you can see, the character slides out from underneath the collision tile there when its head hits it, if you're far enough, if you're close enough to the edge. You'll also note that the way the player sort of slides out is a pixel by pixel slide out, so they move one pixel by one pixel. If you feel like it, you can actually just set it up so that instead it would snap you completely out, so it would cause you to jump all the way to the right immediately. But I think the pixel by pixel slide is somewhat more aesthetically pleasing than a complete snap. So anyways, if you're interested in this more, just go into the collision code and you can take a look at how the collision is working, and you can see, you can do the math behind this for yourself, and you can figure out how it works. So anyways, I think that's everything so far on the ladder state. So I think we'll be getting into some other stuff like our, let's see, what else do I have left here? We have fall state, so fall damage, and then getting some treasure chest and using items. Yeah, that'll probably be something you'll all like. So I think I'll go into the using items first and set up the shop, and then we will move on to fall damage and the character's death state. So thank you very much, everybody, for watching, and good luck with your programming.